So today we're looking at solving exponential equations, and that's when the index or the exponent contains the pronumeral or the missing letter. So to solve for the unknown, you would start by rewriting using the same base. Often the smallest base is best. And second step is if you can't do that, then you have to take logs of both sides. And you always look out for hiding quadratics. Here's our first example. This is one where you can write 16 as 2 to the power of something. So we can write 16 as 2 to the power of 4. Now the left hand side was just the same. And you can see that now that we have the 2 as the common bases, you can equate the indices. So let's make them equal. 1 minus x equals 4. A little bit of a trick to get x by itself is to swap the 4 with the x. So you have 1 minus 4 equals x, and then that gives us negative 3 equals x, which is our final answer. Now, if that little trick wasn't something that sat right with you, you could do it the old way. You could go from here, 1 equals 4 plus x, by adding x to both sides to go from there to there. And then from here you want to get rid of the 4 by subtracting. So you have 1 minus 4 equals x. And then the rest is the same from there onwards. Okay, here's another one where you have to write everything to the same base. In this case, base 5 makes sense because it's the smallest one. So you get 5 to the power of x times 5 squared to the power of 2x minus 3 equals 5 to the power of 4. Now, in practice, we tend to write this first, and that's fine. And the main thing is that you would then expand this bracket here. So here's what we get. 5 to the power of x times 5 to the power of 4x minus 6 equals 5 to the power of 4. And now you can apply the multiplicative index law. You can add these together on the left-hand side. So you get 5 to the power of 5x minus 6 equals 5 to the power of 4. And now because you have the same base, you can equate the index. So you get 5x minus 6 equals 4. And if you add 6 to both sides, you get 5x equals 10. And if you divide by 5, you get x equals 2. Now this one is, believe it or not, a hiding quadratic. That's because 4 can be written as 2 squared. So if we rewrite that, that 4 becomes 2 squared. Everything else will stay the same. And you can hopefully see that if I expand this bracket, I get 2 to the power of x squared equals, minus, that's not going to be very happy, minus 2 to the power of x times 2 to the power of 3 plus 16 equals 0. A little bit of a hint here. 2 to the power of 3 is 8, and so you can write this as 8 times 2 to the power of x, and everything else staying the same for now. The trick with this is to make a substitution. So we want to substitute the 2 to the power of x out. So we'll call it k. Let k equal 2 to the power of x. Then we have k squared minus 8k plus 16 equals 0. You can factorize this to k minus 4 and k minus 4, and that means k equals 4 is the only solution that works. Then when you substitute back in, you get 2 to the power of x equals 4. That's an x there. Therefore, x has to equal 2. Okay, so this one is one where you can't write everything to the base 2 because 12 is not a power of 2. So in this case, we need to take logs of both sides. Easiest log to take is the base that's already written. So we just write log to the base 2 of 2 to the power of x plus 1 equals log to the base 2 of 12. Now this is where you use the trick where you can bring down this power into the front. So you've got x plus 1 times log 2 of 2 equals log 2 of 12. And hopefully you remember that this is just 1, because log of the same base is 1. So you're left with x plus 1 equals log 2 of 12, which means x equals log 2 of 12, take away 1. And if you want to be super careful, put brackets around all your logs, like that. And last but not least, if you were to use your calculator, you would get a number, and we round it off to 2 decimal places. It's 2.58. Okay, so E is the next common base, and E is Euler's number. If you're a German, that's how you say E-U-L-E-R. It's an irrational number. It actually does keep on going forever and ever, but we approximate it to 2.718, which is correct to 3 decimal places. You can just treat it like any other number. You've just got to remember it's not a variable. So here's one. Solve e to the power of 3x equals e. So you should hopefully remember that you can write any number as a power of itself to the power of 1. And then you can equate the indices because the bases are the same. So you have 3x equals 1. And then to get the x by itself, you have to divide by 3. So you get x equals 1/3. Okay, believe it or not, this one's a hiding quadratic as well. And you have to use this special trick over in this corner here, where you have e to the power of x times e to the power of negative x equals 1. Now, if you don't believe me, you can write it out in full, like this. E to the power of x down the bottom. And you can see, hopefully, that these will cancel off, which leaves you with 1/1, which is the same as 1. So what you do is, in your first step, you want to get rid of this negative power of x here, and to do that you would multiply everything by e to the power of positive x. So that means this term becomes e to the power of 2x, and this term becomes 1 by this principle over here, so you end up with -3 there, and it equals 2 times e to the x. Okay, then what we'll have is a quadratic. We will rearrange it so everything's on the left. E to the power of 2x minus 2 e to the x minus 3 equals 0. And here if we allow or let q in this case equal e to the x, that what you have is q squared minus 2q minus 3 equals 0. So from before we had q squared minus 2q minus 3 equals 0, and that factorizes very nicely to q take away 3 and q plus 1 equaling 0. By the null factor law, you get q equals 3 and q equals -1. And if you substitute back in for q equals e to the x, you end up with e to the x equaling 3 and e to the x equaling -1. But you can't have that happening because e to the x is always positive. So the only thing that works is going to be e to the x equal 3. Now if you were to finish that off, you would want to find x by itself, so you have to take log e of both sides, and then we can bring this power down to the front here, so we get x times log e of e equaling log e of 3. And hopefully remember that that cancels off to 1, so that gives you x equals log e of 3. Now you might find it written that you get ln of 3, and that's just the way of writing anything that is log to the base e. It's natural log.